Yeah, hello everyone. So, in the last class, we discussed about some of the conversions and what are the number systems we are using. Uh, so, in that, we were discussed some of the conversion like hexadecimal value. So, what are the positional values? How to take the positional values for binary number system, hexadecimal number system, octal number system, and decimal number system. So here in this class we are going to see about the steps for binary to decimal conversion. So how to convert a binary number, given binary number, into a decimal number, that means base 2 to base 10, how we can convert here. So here what is that, it is given one of the example, it is given like 10.111 base 2. So you have to convert this into the decimal conversion. So here what is that, integer part is present and fractional part is also present. So here in this case we have to write down that binary point. So middle after 1 0 the binary point is there, so after 1 1 1 is there. So here we have to take that integer part separately and fractional part separately. So between that we are having a binary point is present. So for the integer part we have to start from LSB. So LSB, that is 0, and MSB 1, moving from right to left. We are moving from right to left here in this case. So like this we are moving in this case, and for the fractional part we are moving from left side to the right side here. So here we have to specify when the integer part we are considering it is 0 is present, so that means we are starting from 2 power 0, and the next one is 2 power 1, like this. So if it is present, next number is present, you have to write it as 2 power 2, like that. So for the fractional part we are moving from so what is that, from left side to the right side, like this, starting with the 2 power minus 1, 2 power minus 2, 2 power minus 3. So like this we are writing that decimal what is that, binary powers. So after that we have to multiply that each number. So that is 1 is multiplied with 2 power 1, next plus 0 is multiplied with 2 power 0, next 1 is multiplied with 2 power minus 1, next one is multiplied with 2 power minus 2, next one is multiplied with 2 power minus 3. So by adding all these things we are getting like this. So at last we can add multiply and add these numbers, then we will get the result like this, 2.875 base 10 is the conversion, how we can convert this binary number into a base of 10, that is decimal conversion. So here how to convert a binary number into octal number here. So in this case, for example, a binary number is given with the base 2, and we have to convert it into the octal number, that is base 8. So already we know that the 8 means we have to write it as 2 power 3, power of 3 here. That means 3 binary numbers we can group it as we can what is that, include as one group. So when we'll have that number like this 1000111.1000011, so you have to divide this number. So actually we'll get that combined number in this one, like 010 100 111 combined integer part dot binary point with 100011 as the fractional part here. So here we have to convert as a group of 3 bits here. So here integer part is there, here this is the integer part, this is the fractional part is there. So the integer part we are dividing that 3 numbers, okay, moving from right to left here, moving from right to left, and moving from left to right in the fractional part here, like this. So here we are dividing this 111 as one group, 100 as one group, and 010 as one group. So in this case 010, that is equivalent to 2, and 100 is include what is it is equals to 5, 111 it is equals to 7. So here the binary point is going to the octal point, next 100 is 4, and 011 is 3. So how we are getting this one, how we are getting these numbers here? So here for this one we are using a code called as 421. We are using that code 421. So in this case when we write like 010, okay, so here in this case what is, where the 1 is present, at which position the 1 is present, here at position 2 the 1 is present, so just we are writing that number here 2. So in the next case what is that, 100 is present. So in this case, when we equals to 4 to 1 code, so the 1 is present in the place of 4. So and what is that? So here it is mistake, it is given, so it is equals to 4 here. So next one, 1 is present. So in this case 4 2 1, all the three ones are present, so we have to add these three numbers, 4 plus 2 plus 1, that means 7 is the, what is that, binary octal equivalent for the binary number 111. Next 100 is equals to 4 and 011 is equals to 3. So you have to, what is that, equal these binary numbers with the 421 code. So you have to remember this code 42. So next, how to convert the what is that, binary number into hexadecimal number. So here we have to take the same number like this, the binary number it is given, this is the binary number it is given. So this is the binary number it is given in the problem. So here in the case of the octal, what is that, octal is 8, the base is 8, that means we are writing 2 power 3. Okay, so whereas hexadecimal base is 16, so we can write that 16 on the power of 2. 2 power of 4, what is that is equals to 16. So that means 4 number of binary bits, it is equals to 1 hexadecimal number. So in this case we are just taking that, dividing that numbers. Okay, so it is, what is that, there is no binary point is not there, that means it is only the integer part it is given. So we have to move from right to left here by dividing 4 digits as one group, dividing the 4 digits as one group like this. So in the first group we are getting 0010, and in second group 0111, in the third group 0111, and in the fourth group 1111, 4 ones are present, and in the next group, what is that, only 1 is left. So in this case 1 is left means, so to have, we have to make it as a group of 4 numbers. So we can add 3 more zeros to this number, 3 more zeros to the 1, then it will be converted as a hexadecimal number. So how to convert these numbers into the hexadecimal number? So here we are having one more code, that is, we have to remember, that is 8421 code. In the case of the octal, we are using only 421 code because it is, what is that, only 3 bits are present. But in the case of the hexadecimal number, we are using the 4 digits as one group, so we have to use the total code, that is 8421 code here. So here when we see that 8421 code, so here what is that, only 1 is there, that means 0001 is present. So in the place of the 1 we are having that 1, so we can take just 1 as an answer for that one number, binary number. So next 1111 is present. So when we equal to the 8421 code, so all the ones are present, so we have to add all these numbers, 8 plus 4 plus 2 plus 1, that means 8 plus 4 12, 12 plus 2 14, 14 plus 1 15. We cannot write the 15 number in the hexadecimal number because it is equivalent to that alphabet that is equals to F here. So in the place of the 15 we have to write F, so that's why we are writing F here. So whereas 0111, so it is having, so in this case 8421 code we are writing. So in the case of the 8 place, what is that, we are having 0, so we can include, what is that, we are not including that one. So just we are including these numbers only because of having ones in the binary numbers. So we have to add 4 plus 2 plus 1, total 6 plus 7, that is, we are getting that answer 7. So same 0111 7 and 0010 means in the place of the 2 we are having that, what is that, binary number 1. So we can write these numbers like this in the hexadecimal format. So already we know that hexadecimal is a alphanumeric number system. So that means it includes the alphabets and also the numbers. So the numbers are from 0 to 9 and the alphabets are from A to F. That means 10 to 15. Okay, the number 10 to 15 we are writing as a alphabets A to F here. So this is what, how to convert a binary number, given binary number into a hexadecimal number. Base 2 to base 16 we are converting. Next one, decimal number system. So here how to convert a binary number into a decimal number. So in this case, what is that, we have to divide this number. The given decimal number can be divided. Okay, so here we are converting the decimal to binary. That means base 10 to base 2. We have to divide these numbers with 2 here. So here we have to divide this into a successful division, like the number 35 is given. So this, what is the divide with 2? So when we are dividing 35 with 2 means we are getting 17 as a quotient and 1 is the remainder. So successfully we have to divide all these divisions. So at last, what is that, we are getting that 1 is that what is that quotient, and at last 0 is the remainder. So here up to this one we are dividing these the given number. After that, what is that, we have to write that resultant binary number from downwards to upwards like this, starting from 1 0 0 and 0 1 1 like this. We are writing this number, that means equivalent binary number can be converted from downwards to the upwards, right, like this. Next, so how to convert a decimal number into octal conversion? So here in this case also we are dividing that the given decimal number, that is 214, it is given with base 10, that is we are dividing with 8 here. Octal means base is 8, so we are dividing that 214 with 8 here. So when we divide 214, 8 2 is 16, and 5 is the remainder, 5 4 is that, and 8 6 is 48, 54 minus 48 is 6 is the remainder. So we are writing that 6 here like this. And the next one, what is that, what is the next one, we are having 26. So 8 3s are, we are dividing that, next we are getting 24, 26 minus 4 is 24 is 2, we are getting that remainder as 2. So we cannot divide this 3, so directly we are writing this 8 0, and this 3 is can be going to remainder like this. So this is that remainders we are getting. So these remainders are we are writing from downwards to upwards like this. Then we will get that equivalent octal number for the given decimal number is 326 base 8 like this. So these are the steps we are having. So in decimal to hexadecimal, we divide that number by what is that, in the hexadecimal we are dividing with 16, but in the case of the octal we are dividing with 8 here, and write the remainders in the reverse order to get the equivalent octal number. So all the numbers to the base 10, those are called as decimal numbers here. So next, how to convert the decimal number, given decimal number into hexadecimal number, that means base 10. Okay, we are converting that number with base 10 into base 16 here. So divide the decimal number by 16. So treat that division as an integer division here. So write down the remainder in hexadecimal format, and divide that result again by 16 and treat that division as an integer division. So repeat the step 2 and 3, so until we are getting that 0. Okay, so here what is that, one of the example it is given 2811 is given. So this is that decimal number it is given, we have to convert into the hexadecimal number with base 16. So 2811 is dividing with 16 here. So 16 1 is 16, 28 minus 16 is 12. So and 121 is there, 16 7 ja it is present, 118, and 35 is present, 31 is present. Next one, what is that, 16 5 ja we are getting. So in that case we are getting that remainder of 11. So 11 will be what is that, writing in the hexadecimal format, that is B. So next 16 1 ja and 16 10 0. That means 16 1 ja is 16, 1 5 is present. So that means we are not getting that next number, so that's why we are writing just 0 to write that number next number. So we are having that 15. So 10 cannot be divided, so the 10 can be writing like this only with the remainder. So 10 is equivalent to A, and 15 is equivalent to F, 11 is equivalent to B. So that means A F B. So moving from downwards to upwards, we are writing the remainders. So the result is A F B base 16. For the given decimal number 2811 base 10, that is equivalent to the hexadecimal number AFB base 16. So this is the steps how to convert decimal number into hexadecimal. So in these cases we have to remember, so when you are converting decimal number into any other number systems, So for example, when we are taking decimal number into binary, means we are dividing that number with 2. So when we are dividing decimal number to octal number, means we are dividing that number with 8. Decimal to hexadecimal means we are dividing that decimal number with 16. Okay, the resultant number bases can be taken here to divide that given decimal number. So you have to remember the important point here. So the next one is octal number system. So here already we have seen that binary number system, how to convert the binary number into a octal number. So here the octal number is given, so we have to convert this into binary numbers, means zeros to ones. Octal means 0 to 7 are present, 0 to 7 numbers are there, and we have to divide it, what is that, convert into binary number as zeros and ones here. So already we know that it is, what is that, octal number system, that is equals to 8 base 8, means that is, what is that, we are writing 2 power 3, that means 3 digits of binary number, 3 digits of one group of binary number is equals to one octal number. So here we are writing that by using the 421 code. By using the 421 code we are writing this one. So here 3 means, in the case of 3, what is that, when we add 2 plus 1, 2 plus 1 we are getting the 3. So that's why in the place of 2 1 we are writing what is that, 1 1, and remaining it is 0. So here we have to change, okay, change this one as 0 1 1. Next 5 means, so in the case of 4 2 1, 5 means what is that, where we have to add 4 and 1, 4 and 1 we are adding, so in the middle it is 0. Okay, 1 0 1, 1 0 1, what is it, is equivalent to 5. Next 3 means 0 1 1, 4 means 1 0 0, 6 means 4 to 1 code, when you write this 4 to 1 code, 4 plus 2, that means 1 1 0. Okay, that means 1 1 0 means it is equivalent to number 6, octal number 6. So here this is how to convert an octal number into a binary number, equivalent to binary number. So here the octal point is converting into the binary point like this. Just we have to remember, any octal number is given, when you are converting into binary means just combine the three digits as one group. Just we have to remember the code 421 code. By using the 421 code we can write the equivalent to binary number here. Next, how to convert octal number into decimal number here. So that means base 8 is converted into base 10. So how to convert it? So start the decimal result at 0 and remove the most significant octal digit and add it to the result. So just very easy here. So just we have to write that octal number 25, and we are writing here 8 powers. Okay, so already here what is we are converting it into decimal, so that we are octal decimal means we have to write the powers of 8 here, 8 power 0 and 8 power 1 and 8 power 2 like this. Okay, so starting from LSB to MSB, that is moving from right to left like this. So we are writing 8 power 0 first, next 8 power 2, then after what is that, 8 power 2, next one if any digit is present, 8 power 3, like this we are moving from right to the left like this. What is it, LSB to MSB. Right side, rightmost bit is, this is called as LSB, and leftmost bit is called as MSB, most significant bit. So 8 power 0 and 8 power 1 is there, so just multiply those numbers, 2 into 8 power 1 plus 5 into 8 power 0, just add those things, we are getting 16 plus 5, then 21 is the answer for this. Okay, so this is the steps how to convert octal number, given octal number, that means base 8 into a decimal number base 10. Next, how to convert octal number into hexadecimal number. So these are the important conversions. So here we have to convert octal number into hexadecimal. We cannot convert it directly. So to convert octal number into hexadecimal number, we have two steps are process are present. So the first step is, first we have to convert the given octal number into binary number. Then the second step is, the resultant binary number can be converted into the hexadecimal number. So first step is, what is it, the given octal number is converting into binary number like this. First binary have to convert it, The given number is 752. So already we know that how to convert that octal into binary. That means just writing that number with equivalent of 3 digits as one group. So 2 means we are using the code here 421 code. So just we are writing that 010, in the place of 5 we are writing 101, in the place of 7 we are writing 111, like this. So after converting, just we have to combine these binary numbers. That means like this we have to write those numbers, combine all the equivalent binary numbers. After that, to what is that, you have to convert the binary number into hexadecimal. Already we have seen that to convert it, what is it, we are moving from right to left because it is an integer part. So dividing 4 numbers as one group, 4 numbers as one group. So at last, what is that, 1 is going left here. So for this we are adding 3 zeros to this number. So here in this case we have to use the code. What is that code? We have to use 8421. We have to use 8421 code when we are converting binary into hexadecimal. So here 0001 means what is that, at the place of 1 only we are having that 1, so we are writing this as a 1 here. Next 1110 means 8 plus 4 plus 2, that means total 14 is present. So 14, that is what is that, it is called as, what is that, not E, D, it is E, it is equals to E here. Next 1010 means 1010, that means 8 plus 2, that means 10. Okay, so here also it is wrong, it is A. The answer is 1 E A base 16. This is the correct answer for the given question 752 base 8. So here you have to remember the two steps. Two steps are present when we are converting that octal number into hexadecimal. What are the two steps? The first step is convert octal number, given octal number, into binary number, then convert the resultant binary number into the hexadecimal number. Next, hexadecimal number. So how to convert an hexadecimal number, given hexadecimal number, into binary? So very easy process. Just opposite of the binary to hexadecimal, just we are reversing that one. That means the given hexadecimal number is writing in a binary numbers of 8421 code. That means 4 number of binary digits. Given 4 number of what is that, one number is hexadecimal number is given here. So we have to write each and every number as a 4 number of binary digits. That means if it is given 3 means what is that, we have to add 2 plus 1, that means 1 1, remaining are zeros. That means we have to write 0011 is the equivalent binary number for the hexadecimal number 3. So next one, A means the numerical number for that A is 10. So that means we have to add 8 plus 2, that means 1 and 1, so remaining are zeros here. That means 1010 is the what is the equivalent binary number for the hexadecimal number A. Next one, what is that B? B means 11. The value of B is 11 means what is the how to write that 11 here by using 8421 code. 8 plus 2 plus 1, 10 plus 1 11, so 1011 we are writing like this. This is the 1011, that is B here. Next we can write the 2 like this, 1 0 it is 0 0 0 1 0. That means in the place of 2 only we are writing this one, so remaining all are zeros. So this is 0 0 1 0. So first what is that, we are writing separately, every digit is writing separately with the 4 binary digits, and at last what is that, combine all those numbers. Just combine all the numbers to write the resultant number with base 2. This is what, how to convert that given hexadecimal number into the binary number system. Next, so how to convert that hexadecimal into decimal? So given hexadecimal number base 16, so we have to convert it into the decimal number with base 10. So here the what is that, here it is given integer part is given and fractional part is given, like 54.d2 is given. This is a problem, 54.d2 it is a problem, it is given. So in this case this is the integer part and this is the fractional part. So already we know that for the integer part we have to move like this, and for the fractional part we have to move like this. Okay, So we have to add what is that, write that powers, positional values. We have to write that each place values for this one. So in the case of the 4 we are writing 16 power 0, in here it is 16 power 1. To the fractional part we have to write 16 power minus 1 and 16 power minus 2 like this. So after writing these values you have to multiply this. Each number is multiplied and added. Each number is multiplied and added. So like this. So we can get that result like this. At last, after adding all those things, we are getting the total result as 84.8203125. This is the equivalent decimal number. This is base 10, equivalent to base 10 decimal number for the given hexadecimal number, that is 54.32 like this. Next, how to convert hexadecimal into octal number system. Already we have seen that reverse process, that is how to convert that octal number into hexadecimal number. The same reverse process that is included here when we are converting that hexadecimal to octal. So in the case of the octal to hexadecimal, we have followed the two steps of process. First we have converted octal to binary, next binary to hexadecimal. So in the case of the hexadecimal to octal also, we are having the two steps of process, that is first we have to convert hexadecimal number, given hexadecimal number, into binary number system, binary number, and that binary number is converted into the octal number. So here it is having that one of the example, it is given 1AC. This is the problem, it is given 1AC. This is the hexadecimal number it is given. So first we have to convert this hexadecimal into binary number system. So in the last what is the topic, have seen that how to convert the hexadecimal into binary. So each number is writing as a group of 4 binary digits. Each number is writing as a group of 4 binary digits like this. One is writing with using that code 8421 code. By using 8421 code, the number 1, that is equivalent to like this 0001. 0001 is the equivalent to binary number. So next A is 1010, C is 1100. So what is the value of C means? What is that? A means 10, B means 11, C is equals to 12. That means, so how to get the 12 here? By using the 8421 code, by adding 8 plus 4. That means in the place of 8 and 4 we are having 1, remaining are zeros. That means 110 is the 00 is the equivalent number for the C here. So just we are writing that each digit as a group of 4 binary bits like this. Then after combined these binary numbers, we are getting that total binary number for that given hexadecimal number. So after that we have to convert this resultant binary number into the octal number. So how to convert it? So we have to divide these binary numbers as a 3 bits as one group like this. So moving from right to left. Why? Because here it is the integer part we are having. There is no binary point is present in the resultant number, so only integer part is present. So we are moving just from right to the left like this. So the 100, it is equivalent to 4, 101 is 5, 110 is 6, and 00 is 0. That means how to get this? By using the code 421. By using the code 421 equivalent, then we will get these results like 0654. So what is the total? The resultant octal number is, that is 0654 base 8. This is the base 8. We have to write like this. So the next one, so up to this one we have completed all the conversions, like hexadecimal to octal conversion, hexadecimal to decimal conversions, hexadecimal to binary conversions, and the next one, what is before that one, octal to hexadecimal conversions, and octal to decimal conversions, and octal to binary conversions, and the next one is what is a decimal number into hexadecimal number system, and so many of number conversions we have seen here. And in the next case we are having one of the most important topic, that is called as complements. What is mean by the complements here? So they are called as binary complements also. So the binary complements are used to represent the negative numbers, and here in this case we are having two complements are present. They are called as ones complement, and one more is two's complement. What is mean by ones complement and what is mean by two's complement here? So this is ones complement and this is a two's complement. So ones complement is called, what is that? Inverting of all the bits. Inversion of the bits means zeros are written as 1 and 1 is written as 0 here. So here one of the number it is given 0 0 1 1 0 0 1 1 it is given. So the ones complement for this one number is 1 1 0 0 1 1 0 0. Just we, in the place of zeros we are putting that ones, and in the place of ones we are putting the zeros like this. This is called as negation. That means just we are writing that zeros to ones and ones to zeros. That is called as ones complement. And what is mean by two's complement here? So already we know that what is mean by ones complement. Just by inverting that numbers zeros to ones and ones to zeros, by adding ones, by adding 1 to the ones complement, then we will get two's complement like this. So here two's complement we are writing this for this number 0 0 1 1 0 0 1 1. So first we are converting this number into ones complement, then add 1 to that binary resultant number, then we are getting that two's complement of that number 1 1 0 0 1 1 0 1 like this. So these are the complements. One's complement as two's complements are used to represent the negative numbers. These are the representation for negative numbers. To add and to subtract the two different types of the numbers, we are using these binary complements. So this is what is that we can, how we can convert the different conversions, and how to calculate the binary complements like ones complement and two's complement. So in the further class we will see how to subtract that ones complement, and by using ones complement and by using two's complement, how to subtract the two numbers in the next class. Thank you.